Hi there, this is an AQA GCSE 91 Physics paper, okay, and this one is about an experiment. Pause the video and have a little read, have a little go yourself, have a little think about it at the very least, okay. I'm not going to read it all, so when you do read it, focus on the command words. So here we just have to give one variable the student controlled in their investigation. So having a little read through here, we can see he's going to measure the speed the way it was lifted and calculate the efficiency. He's always using 2.5 newtons and a height of 2 meters. He's going to vary the speed and then calculate the efficiency. So what does he control? It's either the weight or it's the height. So I'm going to go for weight personally, but height perfectly valid as well. Nice simple mark, didn't need too much thinking because of that command word there. Give, again, 2 reasons for taking repeat readings in an investigation. So here, a lot of people are giving me things about this specific investigation. So they were saying, well, the height could have been different each time, the weight could have changed, or the speed could have changed to the motor, but it's talking about generally in any investigation. So why do we take repeat readings, essentially? It's so you can identify anomalies, okay, or you might call them outliers, and it's so that we can calculate an accurate average and calculate a mean. Okay, those are the 2 most obvious ones. If you do that though, and there were some random errors, then by repeating it, you can get closer to the true value by eliminating or reducing the effect of the random errors. That's the last one there. So I think these ones are useful ones for thinking about the difference between accuracy and precision. So accurate mean, precise data. So think about those 2 words whenever you're talking about what we do with the data. It's always going to be about how accurate you are, how close to the true value you are. That's what it means. How precise you are, how spread out is your data. Okay, next. Again, give 2 conclusions that could be made from the data in figure 5. That's the graph, basically figure 5. So although this is just a give one, it's not, remember, you have to actually solve it from the graph. This is the AO3 skill so far, using interpreting data, coming up with conclusions and evaluations, that type of thing. Typically, most thinking needs to go into this. So 2 conclusions that can be made from the data. Well, you can see as the efficiency increases, speed increases. Well, you might want to say that the other way around, because he's varied the speed and measured the efficiency. That's going to be my first conclusion. As speed increases, efficiency increases. Not they are proportional to each other. It would not be the case if I double the speed, I get double the efficiency. That's not the case. So you've got to be really careful with that. It's not a straight line through the origin. They're not proportional. So we're just looking for increases here. Okay, but that's only one of the conclusions, so make sure that you're actually doing all that you're asked to do. You can see it's starting to curve, but just say it's a curve is not quite good enough for the mark, okay? Well, what is it we know about efficiency that means it's probably going to curve? You can't ever be more efficient than 100%. You can't really be 100% efficient either. So what's happening here is it's getting more efficient, but it's going to reach a limit. Okay, so efficiency goes towards a limit or a plateau. The graph is going to plateau, won't get above a certain efficiency. So I think I'm just going to go that. Efficiency seems to increase towards a limit. You might have said something like, there's a maximum efficiency that you're likely to be able to get to. Mark for this, mark for that. Give the main way motor is likely to waste energy. Now, in the previous syllabi, then saying heat and sound, whenever you saw waste energy was going to be good enough. Okay. Now we're not looking for heat or sound because we've kind of changed the way we want you to think about energy. What's happening is it is heating. So energy is being transferred in a heating effect, the surroundings. So it's no harder really. It's still, if you see waste energy, heating the surroundings. This is a fundamental law in physics, the first law of thermodynamics, basically, that energy is going to tend to spread out. Okay, and all transfers we have waste energy by heating the surroundings. Okay, so not just heat, not just sound. If you said a specific surrounding, so if you said, oh, it's probably heating the motor as it goes, then that would be okay as well. But so specific surrounding would be okay. Here's quite a good one. Now here's a funny one because it looks like a calculation question at first, but then it just says state. And it's only worth 1 mark. So they're not looking for you to actually get any numbers and use your calculator to work anything out. Okay, when the total power input to the motor was 5 watts, the motor could not lift the 2.5 Newton weight. So you've got to think about what you know about efficiency here to get this one right. Well, efficiency is the ratio of useful transfer of energy or power over the total. So let's have a little look at this. Well, talking about power, so the total might be 5 watts here. What's the useful? Well, it could not lift the weight. So the useful is 0. So here what they're really looking for is just for you to recognise if there's no useful energy transfer, then the efficiency has got to be 0%. So it wasn't able to do what you were hoping it would do. Okay, I hope that makes sense. I hope that's really, really useful. I'm Kit Masters, this is Gorilla Physics. This stuff is pretty straightforward once you get your head around it. You just got to do a lot of learning the detail at the level that we want at GCSE. At Gorilla Physics, we're all about you understanding your physics more so that you enjoy it more, so you get more confident and then you're going to do better in your exams. Thanks a lot for watching.